This video looks at an introduction to series. You've come across sequences a lot at GCSE, so the sequence is just a pattern of numbers. A series is a summation of that pattern of numbers. So, for example, 1, 3, 5, 7, 9 is a sequence. 1 plus 3 plus 5 plus 7 plus 9 is a series because we're adding up the numbers in the sequence. A concise way to define a series is to use the sigma notation, because sigma denotes the sum of. We use it in this way. So we have our sigma notation. Underneath we put the starting position, so in this case we start when r is 1, and then above we put the final position in our series, and then the function goes to the right of the sigma notation. So this function is that r is being squared. So r equals 1 to n. For r squared, you just put in 1, then 2, then 3, then 4, and so on, all the way up to n. Obviously we can't write all of that, so we use the ellipsis in the middle here to denote there's a gap, and then put in the last two terms. So r squared will become 1 squared, because we start with 1, then we could go up 2 squared plus 3 squared plus, and then the last two terms will be n minus 1 squared plus n squared. So in our first set of examples, we're just using the sigma notation to write out the series. So here we've got r starts at 1, finishes at n, and our function is 2r minus 1. So all we do, we start by substituting 1 in, then 2, then 3, and so on. So 2 times 1 minus 1 is 1, 2 times 2 minus 1 is 3, 2 times 3 minus 1 is 5, up to 2 times n minus 1, which is 2n minus 1. So remember, it's sigma, so we're summing them, it's a series, so it becomes 1 plus 3 plus 5 plus all the way up to 2n minus 1. This next example, we're starting when r is 0 and going up to n minus 1, and it's for the function 2r plus 1. So again we start substituting in 0 to start, then 1, then 2, and so on. So we get 2 times 0 plus 1, which is 1, plus 2 times 1 plus 1, which is 3, plus 2 times 2 plus 1, which is 5, all the way up to 2 lots of n minus 1 plus 1, which comes up as 2n minus 1. It's a good place to note that these two series come out the same, even though they've got different sigma notation. So depending on how you write out your sigma notation, you could have the same series deriving from it. And then this last one is k is 1 to n of k squared plus 2. So again we're just substituting in 1, then 2, then 3, all the way up to n. So 1 squared plus 2, 2 squared plus 2, 3 squared plus 3, plus n squared plus 2, so we get 3 plus 6 plus 11 plus n squared plus 2. Our second example looks at going the other way. We've got the series and we have to write the sigma notation. It's very useful at this point to be able to remember how to find the nth term of a sequence, because that is what's going to make the function here if it's not already defined for you. So 3 plus 5 plus 7 plus 9 plus 11 plus 13, if we have our nth term of the sequence 3, 5, 7, 9, 11, we're going up in 2s, so it means we've got 2n. 2n is a 2 times table, which starts with 2, and we want to start with 3, so we get 2n plus 1 would be the nth term. So the series here is our 2n plus 1 is our function, but obviously we're using r, so it's 2r plus 1. R starts with 1 because we were using 1 here, and ends, because we stop at 13, that will be 2 times 6 plus 1 will give us the 13, so it stops at 6, or it's 1, 2, 3, 4, 5, the 6th term as well. the next example, we've got 2 plus 5 plus 10 plus a squared plus 1. So it's actually given us the function with our last entry being a, so that's why a is our final position. We're starting with 1 because 1 squared plus 1 will give us the 2. So r is 1 to start, and then the function is r squared plus 1. Sometimes they're written as product. So we've got 1 times 2 plus 2 times 3 plus 3 times 4 all the way up to n minus 2 times n minus 1. So if we look at the pattern, we've got a number times 1 more than it. A number times 1 more than it, a number times 1 more than it. So we can write that as r times r plus 1. Our final entry is n minus 2 times 1 more than it, so n minus 2 is our final position, and our starting position is r is 1 because we're putting 1 in first. Again, there are many variations of defining a series using sigma notation. This 1 times 2 plus 2 times 3 plus 3 times 4 can also be defined as starting with 3. Then comparing this with 3, we've got n minus 2 and r minus 2 and r minus 1, which is what our function will be, and we'll go up to n because then we can put n in here and get our n minus 2, n minus 1 out.